How much of your data do you actually need to keep in order to estimate a parameter? Sometimes a single summary number holds every last drop of information. That's a sufficient statistic. A statistic is sufficient for theta if, once you know its value, the leftover data tell you nothing more about theta. Formally, the distribution of the raw data given the statistic no longer depends on theta. So you can compress the entire dataset down to that one number and lose nothing. Flip a coin n times to estimate its probability of heads. The full record, heads, tails, tails, heads, and on, looks like a lot of information. But only the total count of heads matters. The exact order is irrelevant, so the count is sufficient. How do you spot one? The factorization theorem gives a clean test. If the joint density splits into one piece that touches theta only through the statistic, times another piece free of theta, then the statistic is sufficient. The parameter only ever reaches the data through t, so t carries all of its information. Sufficiency is data reduction without loss, and it pays off everywhere. Good estimators, the maximum likelihood estimate included, always depend on the data only through a sufficient statistic. And the Rao-Blackwell theorem says any estimator can be improved by conditioning on 1. A sufficient statistic compresses the data while keeping all the information about theta. The factorization theorem is the test. The count of successes is the classic example. Next, exactly how much information the data hold, Fisher information, and the Kramer-Rao bound.